MMGIS is a web-based mapping system designed to support mission operations for planetary missions for scientists and engineers. The goal of MMGIS is to address the problem of having spacecraft, and sometimes multiple spacecraft, both orbital, suborbital, and in situ, with tens of instruments, and being able to take that data stream and putting it into a format that's readily accessible. That can be data that's derived, such as elevation models taken from multiple orbital images or slope hazards or rock densities, but also textual data in terms of information from instruments such as chemistry, where you might get an interesting result, but you might not know exactly where it is on the surface. So MMGIS includes a web-based interface that provides multiple views that a geologist would understand, both a view from the orbit, from the map view, typical 2D view, an in situ view to show data on the ground, a 3D view to show data in its true spatial context, as well as the ability to link to descriptive data such as oxide values, such that you can link together results from instruments all back to their proper orientation on a map. Here's an example of MMGIS in action. We have the map in the background. As we zoom in, we see more and more data from this, the rover. This is a Curiosity rover, and we can quickly mouse over targets to find out information about them. We can also have clicked on the rover and then look at the in situ data automatically, and it is loaded based on the information at the waypoint of where the rover is. As you can see, we can zoom around, we can see targets on the ground, certainly a lot better resolution than we do from orbit. Then we can go back and we can see where the actual targets are in relation to the rover. We can even find them in the mosaic, such as Cat Creek here. And then we can switch rover positions and do the same thing. Look at a view from a different location, see where targets have been acquired, see their names, their orientation related to the orbital view. And then we can even look at the data themselves. So now we're looking at the chemistry tool inside of MMGIS, which allows us to look through, in this case, LIBS data, which is looking at the oxides which we can sort and see the raw values for. And we can even combine targets from multiple locations and just create a quick graph so that you can compare different attributes about various samples. In this case, we're going to take a look at aluminum and iron oxides and look for any trends, in which case, here we go. So this is just a quick way to look at data without having to dig through multiple reports. And again, to be able to see data both from the orbital view, the in situ view, and in 3D. So behind MMGIS is it is a web-based application. It is based on Node, and therefore uses a lot of JavaScript and CSS. We also use GDAL and Python in the back end, as well as full spatial database support, Postgres with the PostGIS extension. And we can either serve GJSON or map vector tiles directly out of there, or we can serve them as raw files themselves. These are the vector formats that we support. And then we also have raster data sets, which we typically serve as TMS tiles that we compile from GeoTIFFs, and we also use GDAL virtual raster formats for looking at some data sets to mosaic them together. And we can also read WTMS and WMS layers. And so on the upper right, you can actually see our configuration page where you can configure all the different types of layers with their various attributes and zoom settings and such, so that it is transparent to the user on the other end. So MMGIS is very much designed as a system support tool, not so much a standalone tool, and so thereby when the user goes to MMGIS on the web, they're really getting a kind of curated view of what to see, and they don't see everything, they see exactly what they're supposed to see, so they can complete their operations for the day. And just as a reminder that MMGIS is open source software. You can download it now, and it is under the Apache 2.0 license. So current mission deployments, up in the right hand corner you can see Insight. He's not really using that tool right now since the instruments have deployed, but it was a unique, we did develop this unique targeting tool to allow them to simulate the placement of the seismometer and heat probe onto the surface, including looking at tether management. But active, we're on the Mars Science Laboratory, the Mars 2020 rover, quite active. We were both active pre-landing to do strategic targeting and also currently for campaign operations. We're also being used for joint operations with Mars Sample Return. Right now looking at terrain assessment. ExoMars has used MMGIS as is with no new tools and to do its geologic mapping, similar to as we did on 2020, and the Measures project, which is an EarthBank project, which looks at the displacement of continents as a function of records that are taken by GPS. And so you get coseismic records and velocity vectors, and so the great thing about MMGIS is that we provide all the basics for mapping, and then we add on the extra tool, the one extra tool, and that's where missions will spend their time, developing one extra tool and not 10 extra tools. We'll support any mission to any planet. So on the top left we have my favorite Mars, but also on the right we have the Moon. This is actually a polar stereographic projection, the South Pole, and we're bringing in actually Luniserve data, and this is from the Lunar Viper project. We're working on that mission that will be launching in a couple of years, bringing a Cinder rover to the Moon. The bottom left is some data I pulled in from the Messenger mission to Mercury, just looking at quick looks, and on the bottom right is data from Enceladus. This is the Damascus Tiger Strait. And you can see that the navigations, the capabilities, all pretty much the same. We have the ability to look at things at 2D and 3D. In the case of Mercury, we're looking at quick look data products that were coming from actually the PDS. And on the right hand side, I got some elevation models of this area, and we're able to simulate the view as if you're walking on the surface. And you'll notice that little green dot, that is actually looking at where that viewpoint on the right hand side is actually looking. So this is great actually for looking at mosaics from the ground and then seeing which feature is actually visible. In this case, we're looking at which ridge you actually can see. So it's very useful for operations in that sense. And capabilities of ability to draw distances, and we can actually create haversine great circle arcs with our measure tool. But really in the top left you can see our measurement tool is really used for measuring distances and angles, which is typically how we talk about when we're trying to target something from the ground. It also allows you to create a contour, a profile, elevation profile, which you can search. And the bottom left, you can also see that we have the ability to query different points and data sets and look at more of their metadata. And on the bottom right is actually a tool that's developed for 2020, an enhanced drawing tool, which initially called Campaign Analysis, Mapping, and Planning, but really it's the whole tool now for 2020. So it has the ability to draw polygons, lines, points, text, arrows, and ability to actually intersect the different polygons together, and that way you can actually create topologically correct data sets. Creating data is very important. It's important to do it well, and so we try to make the tool as simple as possible so that scientists of all stripes can enter data in and do mapping and suggest locations where they would like the rover to go. Here's just highlighting some of the newer tools we built. On the left-hand side is going to be for the viewshed tool. I'm not going to talk too much about it, but just to say that we have client-side view shedding capability, and Tarek Solomon will discuss it more during his talk. The top right is the time series tool that we built for looking at these various GPS stations and looking at their seismic records. And then just show some other capabilities in the bottom here, just showing our ability to search through tens to hundreds of layers in a relatively easy way, and how we can turn layers on, look at their legend of their values, and then we have a identifier tool which we can mouse over and actually will read off that legend value, but it can also dig into actual values. Like you can see for the base map, we actually show the elevation at that point when you stop. So for future missions, we're looking for another Earth mission called the Multi-Angle Imager for Aerosols, MAIA, and which is launching in 2022, and we've developed an initial instance of MMGIS for them, and we're just in the beginning stages of developing their sample points. But the mission that we've worked the most on recently actually has been Lunar Viper, which is set to launch in 2023 to the moon. They really needed enhanced real-time support and dynamic data layers, and we're actually making great progress in that, and actual serving data from LunaServe and supporting polar projections, all of which we've put into MMGIS, and we'll probably be releasing the final versions this summer. But we're excitingly looking forward to releasing a new 3D globe viewer called Lithosphere. It would actually be a standalone node module as opposed to being completely integrated into MMGIS, although it is put back into it. And it's going to support things like 3D tiles, 3D JSON, in terms of like you can actually read the elevation value and see orbital paths off the surface, adding 3D support to WMS, and will provide increased activity so you can actually interact with features on the globe. It won't just be drawn on there. We also, because 2020 has a ground penetrating radar, we are looking to develop the so-called curtain data sets, which allows us to look at the 2D profiles from the data on the ground after traverses. And again, we're going to add some more real-time mission support, some of which we've already got through the Viper, but we're hoping to add to support future human missions.